Hello friends, welcome back to India for IS Current Affairs series. Topic of this video is Majorana 1. In this video, we are going to study about why Majorana 1 was in use, what are its key features and its potential applications, what are different types of qubits in quantum computers, followed by one prelims practice question. This topic it is very important for both UPSC prelims and mains. It is important for upcoming prelims 2025. Why? Because the UPSC repeatedly asked questions on quantum computing and qubits, and also this is important for UPSC mains 2025. The reason being the quantum technology is in news every year, and it is a probable topic for upcoming mains. And also the questions may come in KS mains also. KS ಮೇನ್ಸ್ 2025 ಅಲ್ಲೂ ಕೂಡ ಕ್ವಾಂಟಮ್ ಕಂಪ್ಯೂಟಿಂಗ್ ಮೇಲೆ ಕ್ವಶನ್ಸ್ ಬರ್ಬೋದು. ಸೊ ಆ ದೃಷ್ಟಿಯಲ್ಲಿ ಮಜೋರಾನ 1 ಈಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. This topic it falls under GS3 paper of UPSC. Within GS3 it falls under science and technology. Within science and technology the subtopic is information and communication technology and computers. Recently Microsoft it introduced the Majorana 1, and this Majorana 1 is the world's first quantum chip based on a topological core architecture. So it is a quantum computing chip. We know that the chips are being used in electronic devices, computers. So these chips so far we use to manufacture micro and nano scale. Now the chips are being manufactured using quantum technology. So Majorana 1 is the world's first quantum chip based on topological core architecture. So that is the speciality of the Majorana 1. So in the following image we can see the Majorana 1 chip. So now question arises, why Microsoft used the Majorana to name this quantum computing chip? The reason being, in particle physics, Majorana is a Fermi ion called Majorana Fermi ion. It is also called as Majorana particle. And this Majorana particle is a Fermi ion. And this Fermi ion, it was hypothesized by Ettore Majorana. Ettore, a scientist called Ettore Majorana. So these particles were hypothesized by Ettore Majorana in the year 1937. So because of that Fermi ion got the name Majorana. So it is called as Majorana Fermi ion. So the same Majorana has been used for this Microsoft chip. So the quantum chip. One more speciality of the Majorana Fermi ion is they act as their own antiparticles. In physics, we have a particle and also an antiparticle. Each particle has its own antiparticle. So the Majorana Fermi ion, it acts as their own antiparticle. That is the speciality of the Majorana Fermi ions. Now we will look into the key features of the Majorana 1 quantum computing chip. The first feature is topological core architecture. So ಏನಂದ್ರೆ topological core architecture. So topological core architecture means Majorana 1 is the first quantum chip to use topoconductor. Topoconductor ಅಂದ್ರೆ topological superconductor. So this is a new state of matter beyond solids, liquids and gases. So this topological core architecture it uses a topoconductor, and this topoconductor it is a new state of matter beyond solids, liquids and gases. So this unique architecture, that is topological core architecture, enhances the error resistance and quantum stability in the quantum chip. Then coming to the material composition of this Majorana 1 chip, so it is made from indium arsenide and aluminium. So this indium arsenide it is a semiconductor and aluminum is a superconductor. So this enables a stable quantum environment for chip. So Majorana fermi ions. So we have already studied the background of Majorana fermi ions. So in particle physics, there is a particle called fermi ions. So these fermi ions are hypothesized by Ettore Majorana. So because of that, these fermi ions got the Majorana name. And the speciality of the Majorana fermi ions is they act as their own antiparticle, and this phenomena, this speciality has been helped in developing the quantum chip. So these particles, they improve the fault tolerance and reducing the error rate in the quantum computations. Coming to the scalability and performance of the qubits, that is quantum chip. So the currently the quantum chip, it features 8 qubits. So later we will study what is qubits. So the present chip, it features 8 qubits, but the topological core architecture, whatever this Majorana 1 chip, it has a topological core architecture. It enhances, it allows for error resistant scaling up to 1 million qubits. From 8 to, it allows 1 million qubits. So that is the scalability of the Majorana, the core topological core architecture. So this scalability is a crucial step towards achieving practical quantum computing. So this is very, this from 8 to 1 million, this is very important. It is a very crucial step towards achieving the practical quantum computing. So that has been done using topological core architecture. Then the next key feature is quantum advantage. So what is quantum advantage? In digital computer, the classical computers, what we use, it the classical or digital computers, they use binary bits, zeros and ones. So they use binary bits, whereas the quantum computers, they utilize qubits. So these qubits, they exist in multiple states simultaneously. So this phenomena is called as superposition. This superposition, it helps or it enables exponentially faster problem solving for complex computations. So that is the quantum advantage compared to the conventional computers. So that can be used, that can be utilized in quantum computing. So what are the types of qubits in quantum computers so far used? So we have Google's Willow chip and Microsoft Majorana 1. The Google's Willow chip, it uses small circuits mimicking atoms in a quantum state, whereas the Microsoft Majorana 1, it uses Majorana particles, which are elusive subatomic entities in topological superconductors. So the advantage is Majorana based qubits are potentially less error prone than designed by Google and IBM. So compared to the Google and IBM chips, Microsoft Majorana 1 chip, it relies on Majorana particles. These are fermi ions. Majorana are fermi ions. So because of that, the error in the this quantum chip is less compared to the what one designed by Google. Now we will go through some basics, that is quantum chip. So some terminologies associated with quantum chip. So coming to quantum chip, what is quantum chip? Quantum chip is a hardware component that houses quantum bits. These quantum bits, they are also called as qubits, and it is used in quantum computers to perform complex computations. So that is the definition of the quantum chip. So coming to the key features of the quantum chips, the first one is qubits. Qubits ಅಂತಂದ್ರೆ so classical computers ಅಲ್ಲಿ binary bits ಇರುತ್ತೆ, that is zeros and ones. In quantum computer they exist in a superposition of states, that is both 0 and 1 simultaneous ಆಗಿರುತ್ತೆ. ಸೊ ಇದು simultaneous ಆಗಿರೋದನ್ನ superposition, and these bits are very much important in quantum computing, that's why they are called as qubits. Then second one is entanglement. So what is entanglement? Qubits can be entangled, meaning the state of one qubit is dependent on the state of another, enabling faster computers. That is, say for example, we have 0 position and we have 1 position. The state of 0 position is dependent on state of 1 position, and state of 1 position is dependent on state of 0 position. So this phenomena is called as entanglement, and it is very important for quantum computing because it enables faster computations. Then we have quantum gates, the third important terminology. So quantum chips use quantum gates to manipulate qubits, performing operations like superposition, entanglement, and interference. So ಏನಿದ್ರ ಅರ್ಥ ಅಂತಂದ್ರೆ we have logical gates in normal chips, whatever chips that we are using now. So these normal chips, they use logical gates to perform certain functions. In the same way, the quantum chip, they uses quantum gates in order to manipulate the qubits so that they can perform various functions. Now we will look into the types of quantum chips. So there are various types of quantum chips. The one that are used superconducting qubits. So these are used by companies like IBM and Google. So operating at extremely low temperatures. The superconducting qubits, they operate at extremely low temperatures. Then we have trapped ion qubits. So these, they uses ions trapped in electromagnetic fields. They are known for high precision computation. Then we have photonic chips. The photonic chips, they use photons. What are photons? They are light particles. Photons are light particles for and photonic chips, they use photons for quantum computations, and they are suitable for quantum communication technology. Then we have topological qubits. So they are theoretical and experimental, focusing on error-resistant qubits. So whatever Microsoft developed, that is Majorana 1. So it is a Majorana 1. It is a topological qubit. Coming to the application of the potential application of Majorana 1 quantum chip. So first one, in environmental science study. So what is its application in environmental science study? So this will help in breaking down the microplastics, addressing global pollution challenges. So the chip can be used in breaking down the microplastic, addressing global plastic pollution challenges. Second application in material science. So this enables the development of self-healing materials with advanced properties. Self-healing materials ಅಂತಂದ್ರೆ, if any material, if it is broken, it will heal on its own and it will become as it is earlier again. So that is a self-healing property. The third application is healthcare and drug discovery. So the quantum chip, it accelerates research in drug development, personalized medicine, and medical diagnostic. Then the fourth application is complex problem solving in fields like chemistry, cryptography, artificial intelligence, and material science. So this is all about Majorana 1 chip. So why it was in use, its key features, potential applications. Based on the topic that we have discussed so far, that is Majorana 1 quantum chip. So here we have provided one prelims practice question. It contains 4 options. Go through all the 4 options and comment your answer. The answer and detailed explanation for this question is available in the PDF handout, which you can download by joining our Telegram channel. Thank you for watching. See you in the next video. Till then, happy learning.